Good morning, everyone. Today we will see graph algorithm traversal approach, deep depth first search. First, we will see what is graph. Graph is a mathematical structure used to model some objects and relationship between the objects. It consists of two elements, vertices and edges. Vertices are node called as objects in a graph. This is a fundamental unit or a point in a graph. And edges, it is a line, it connects two objects or two vertices. It creates a relationship between two objects or two vertices. It's a path between two objects. A graph G is defined as collection of vertices and edges. G is equal to V comma E, where V is a set of vertices and E is a set of edges connecting pair of vertices. See the graph G1. V vertices list are A, B, C, D. There are four nodes. And see the second example. Find out the edges. Edges means connecting two vertices. See the second graph. AD, AC, DC, BC, BE and CE. There are six vertices in the second graph. First graph there are four vertices. And what is graph traversal or search? Graph traversal means visiting each node in a graph exactly once, following the connections or edges between them. So graph traversal is a process of visiting all the nodes exactly once. It is a fundamental concept in graph theory. It is used in various algorithms to explore the structure of a graph and network-related problems. The goal is to explore the graph, ensuring no vertices is missed. So visit all the vertices without visiting or missing single node in a graph. This exploration can be done in different orders, leading to various traversal algorithms. Common traversal algorithms include depth first search and breadth first search algorithm. We will see the types of traversal algorithms, depth first and breadth first search. These algorithms are classified based on the order of node visiting in a graph. In which order we are going to visit the node. Based on this, search algorithm is classified into two types, that is depth first search and breadth first search. Graph traversal is important for searching a specific node in a graph. There are 100 elements or 100 objects. We can use the graph for searching a particular element and finding a path or cycle. So if we want to find a path from one object to another object, so we can traverse, we can explore from one node to another node by following the edges, visiting the nodes one by one. It is used to find the path or cycles. It's any cycle, closed loop in a graph and directing connectivity, whether the components or objects are connected or disconnected, that can be identified by using graph traversal algorithm and solving puzzles and mazes. So finding all possible paths, and it can be used to routing in network problems. It's mainly used for routing. The network is represented in the form of graph. We can find the path from one computer to another computer. We can find the shortest path. We can find the loop. So graph traversal plays important role in computer networks. And we will see what is depth first search. Explores as far as possible down one path before backtracking. That is, the traversal performed in only one path or one direction. If we get the result in one path or not possible to explore further, we can stop and move back to the previous option, find alternate. That is called depth first search. And uses stack. It uses data structures called stack. That is, the property lost in first out. So backtracking approach, it use recursive algorithm or recursive concept, because an algorithm is developed in depth first search for backtracking using stack the property lost in first out. It is suitable for exploring all possible paths or checking connectivity. So see the tree. So how to traverse a tree using depth first search. So starting node is always A. Minimum alphabet or minimum number is starting node A. Then visit the first adjacent node. Only the first adjacent node. What are the adjacent nodes for A? B, C, D. There are three adjacent nodes for A, B, C, D. The minimum alphabet is B. So visit the node B first. From A to B, visited. And from B, visit the first adjacent node. So there are two adjacent nodes E and F. Visit the first adjacent, that is E. Now A, B, E is visited. Now from E, we can't explore. There is no path. So move back to the previous node B. Find another node. So move back to B. Find another node F. F is another next fourth visitor node. Add in the DFS path. Then from F, there's no node to explore, so move back to B. From B also there is no node for explore, already E and F is visited. Again from B move back to root A, find another neighbor node, that is C. Then from A visit C. After F, C is visited. From C, then left G. Then move back to C, then visit H. Now all other nodes of C is visited. Again move back to A. So from A, third option is D. Then visit D, then left H, then I. Now see, all nodes are visited. There is no duplication. Okay, so this is called depth first search, exploring all the nodes in depth wise order. That is called depth first search. And we will see one example. Given undirected graph G, it contains 5 nodes A, B, C, D, E. And how to find the DFS path, how to explore the nodes by using depth first search concept. So find the adjacency list. Adjacency list means for all the nodes, find the neighbor node. For A, B and C is a neighbor node. For B, there are 3 edges connected with B. So 3 are neighbor nodes. So A, C, D, write in alphabetical order. That is easy for implementation. So A, C, D. Then for C, 3 adjacent nodes A, B, E. So write in alphabetical order A, B, E. For D, B, E. For E, C, D. First, develop a adjacency list. Then step 1, we have array and stack. We are using stack lost in first out for depth first search implementation, and array is used for storing whether the node is visited or unvisited. Initially array size is 5, number of node is 5, n equal to 5, so array size is 5. So initially array values are 0 for A 0, B 0, that means nodes are unvisited. 0 means node unvisited. If it is visited, the value will be changed to 1. Initially, the stack is empty. We didn't visit any node, so stack is empty. DFS path is empty. This is the initial stage. All nodes are assigned as unvisited. Create a stack and adjacency list. Initially, DFS path is empty. Now, visit the starting node A. Now, node A is visited. So, store A in a stack and change the value of visited node A to 1. That means A is visited. So add the node in a DFS path, traversal path. A is visited. Then from A, see, what are the adjacent node for A? See the adjacency matrix B and C. So visit only the node B. That is next step. So visit only the first adjacent. That is called stack. Visit only the first adjacent B. So add B in the stack. Make remove A from the stack and change the value of B as 1, that is B is visited. Now add the node B in a DFS path. Now from A to B is visited. Next step, what is the adjacent node for B? A, C, D. So remove the element from the stack B, see the neighbor node. For B, A, C, D is adjacent node. So A is already visited. So we should not visit again. So remove A, then take C. For adjacent node B, the node is C. Add C in a stack. Make C is visited. Add C in a path. So from A to B, B to C. Then now pop the element, that is C from the stack. Now, what are the adjacent node for C? A, B, E. C, A, B is already visited. Value is 1. So, unvisited is E. Now, we can visit the node E. That is the fifth step. A, B, C. First adjacent node of C is E. Next, fourth, E is visited. So, see the visited array. Value of E is changed to 1. Add the node E in a DFS path. Now, next. Now, what is the adjacent node for E? That is C and D. C is already visited. So, we have to visit only unvisited node. So, visit only left out is D. D is adjacent node for E. So, visit the node D. So, change the value of D to 1. Now, see all elements values are 1. That means all nodes are visited once. So, add node in a D node in a DFS path. Write in the visiting order. First A is visited, B is visited, A to B, B to C, C to E, then E to D. Then all 5 nodes are visited. Then after removing all the element, that stack will become empty. Now all the nodes are visited. So this is the process of depth first search. Start at the root node, visit the first adjacent, which is the first adjacent. If there is no more adjacent node, again move back to the previous and find another possibilities. That is the example of depth first search. Then what is breadth first search? Searching the element level by level. One level, then next level. Start at A, then visit all adjacent of A. So in DFS, we are visiting only the first adjacent. Only one adjacent at a time. But in the case of breadth first search, visit all the adjacent of particular node. That is level 1. A, B, C, D. The next level, E, F, G, H, I, J. This is the order of traversal in breadth first search. And what are the applications of graph traverse? It is used to find the path between two pair of objects and mass solving to check all the possibilities for solving or for finding the path. Topological sorting. So DFS is used in topological sorting. Detecting cycle. If we have set of elements, we can find by using DFS is any cycle in the graph or not. And connected components. So the component, all the nodes are connected or disconnected. So we can check the connected or disconnected property using depth first search approach and topological set. And time complexity. V is number of vertices, N is number of edges. We are developing adjacency matrix, that is two-dimensional array V into V size. And if we use adjacency list for implementation, time complexity is order of V plus E. If we use adjacency matrix, that is size is V cross V. So time complexity is order of V square, because total operation is V into V. Time complexity is order of V square. In the worst case scenario, DFS explores every vertex, every edge to find a solution. Use adjacency matrix when the graph is dense, many edges. So if the graph contains more number of edges, we can go for adjacency matrix. If the graph is sparse or it has only fewer edges, adjacency list is efficient. That takes only order of V plus E time complexity. What's the difference between BFS and DFS? Traversal order, breadth first search, level by level. Depth first will go in one path, then backtrack. Here, BFS uses FIFO property, first in, first out queue. DFS uses last in, first out, that is stack. Here, recursive concept is implemented because of backtracking approach. Implementation, iterative using queue. We are using for loop or while loop, iterative looping statement for implementation for queue. Here, we are using depth first search is a recursion. So, it's an iterative, recursive iterative using stack. Shortest path. Yes, find shortest path in unweighted graphs. So it does not guarantee the shortest path. And space complexity is order of V plus order of V, the worst case. Here in DFS, space complexity is order of H. Height is depth of the tree. H is height of the tree or depth of the tree. And time complexity is BFS. If we use adjacency list, V plus E for both. If you use adjacency matrix, order of V square. Best use case, finding shortest path, level order traversal. Exploring the entire graph, checking connectivity or cycles. So it's complete travel, yes, for both. Backtracking, in BFS no backtracking, and DFS there's a backtracking. Thank you.